Namaskar. Let us see a new application for a stepper motor. Okay, so we will be seeing the motor driver which will be driving our stepper motors. This is a device MAX22211, that is MAX22211. This is newly introduced device from analog devices, and it can work up to 36 volts input and 3.8 volt output, 3.8 ampere output. It has two half bridge for dual brushed or single stepper motor. Means you can run up to two brush motors or one single stepper motors. All right. So let us see quickly the general descriptions and the applications, and then we will move to the design stage. Okay. So let's open datasheet for this. First of all, let's go to the product page of analog devices, and once we search for Max 22211 series, we get this particular device. It is telling you that it has two half bridge for dual brushed or single stepper motor drivers. All right. If you want, you can download the data sheet and everything, and you can see you have features and product details that we will see in the data sheet. All right. So let us see. It has so many controls and all those design stages that we will see through the pin description. Okay. Very first thing that you have to understand is the benefits. Okay. So the benefits is it can work up to 36 volt. Okay, I will tell you what are the applications that you will be using this for. The current rating is maximum is 3.8, but I'll suggest you go ahead with 2 ampere RMS current. That is maximum, like 2 ampere current is better. It has current drive regulations. Okay, so like current drive regulation for A and B, two half bridges are there, so for those you can regulate the currents output. It has four decay modes. Basically you can like change your decay mode: slow decay mode, fast decay mode, or mixed decay mode. Okay. That we'll see during the design as well. And it has half full scale pin to improve current accuracy. Okay, so you want to control your current output from the motor driver, that also you can control using HFS pin. All right. What are the other things? It has current sense output, means how much current is going through the motor driver output, okay, pins. That current you can sense through the I sense. Okay, I sense pin is there. Then fault indication pin is there. Like if you have any like fault in the motor, then it will drive it low so that you can get indicated like, okay, I mean IC is in fault position. It has low power modes, like it has sleep mode or something like that, so you can put that motor driver into sleep mode by putting the sleep pin high or low based on the requirements. It has overcurrent protection, like if you are like running through short circuit or something like that, then there will be overcurrent, that will be protection is there. Under voltage lockout, suppose your application is for 12 volt, but your input is just like a 9 volt or 8 volt, or maybe it is less than 4.5 volt. Okay, then it will be locked out, means the IC will not be working. It has thermal shutdown as well, so once the junction temperature increases to more than 165 degrees centigrade, it switches off. Okay, and the best thing is it has two pin packages. One is TQFN 32 pin, and another one is TSSOP 28 pin. So actually both of the like devices are same. Four more pins are there which are actually not connected pin. So actually both of them are exactly same functionality wise. So I'll suggest you go ahead with TSSOP 28 for easy like handling and everything. Got it? So let us proceed like a simplified block diagram. It is kind of a circuit only. So you will need two things. One is one microcontroller. So I have already designed with microcontroller, that is MSP M0L1306. I have given you tutorial for 1105 series. Okay, and next little bit higher version is 1306. Okay, so this is better one. It is 32 pin package. Okay, VQFN package. Now coming to the motor driver part number, which is MAX22211. One more thing is, before proceeding to this, you can have your own microcontroller as well. Like if you are using very high-end microcontroller of some 100 pins or 144 pins or something like that in your project, still it is good. You just need some pins to drive this particular motor driver. Okay, got it? So moving to the simplified block diagram. So I told you this is D in pin. So D in pin actually will be used for your PWM inputs, like how going to make it fast or slow. So this will be your PWM inputs. Okay. So D in pins are actually 4 pins: D in 1A, 1B, 2A, 2B, something like that. Then I sense pin is there. How much current is going through the microcontroller? Sorry, this motor driver outputs. Okay, so I sense A and I sense B will be there. Okay. Then we have current drive regulation. So current drive regulation, A will be there and B will be there. Okay. So that will be given to the microcontroller. Analog, ADCs or something like that, you can take up to measure that. Fault indication. So if the IC is in faulty position, then fault will be triggered. Similarly, if you want to enable which one bridge, like enable A or enable B, there are two bridges. This is A and this is B. Okay. So enable A means only one will be enabled. Enable A and B both, then both will be enabled. Okay. Then decay mode setting is there. So DK1 and DK2 are there. All right. And we have HFS pin. HFS pin, just now I told you, half full scale pin. Okay. So it will be basically used for controlling the current accuracy. So current accuracy. And ref pin are actually used for setting up the current. So RF, ref A and ref B will be available. All right. Good. So with this, I think we can go ahead and design the circuit for this particular stepper motor driver. Okay. One more advantage is, you can see this stepper motor IC can be used to drive brushed DC motors. So one output will be able to drive one DC motor and another will be for another one. So total two brushed DC motor can be driven. If you want to drive for a stepper motor, you will be able to drive only one of them. Okay. Now let's see the some of the absolute maximum ratings and all those things. So before that, what we'll see is, we'll go ahead and see the applications for this. Okay. So once we proceed to application, as you saw that this is a stepper motor driver. So whichever applications or whichever devices that utilizes your stepper motors, there it can be used. Okay. And more importantly, I'll tell you the voltage levels for which you can utilize. So this will be most suitable for your, let's say, 9-volt application, 12-volt application, 15-volt application, 18-volt application, 24-volt application, and 30-volt application. I'll suggest you only this voltage range applications you try to utilize, and maximum current you take out is 2 ampere. Okay. So up to 2 ampere current, if you need, you try to use this particular IC. If you are going for little lower voltage, then you can still go ahead up to around 3 ampere, but I'll suggest go ahead with 2 ampere max. Okay. Next, it can be used for brush DC motor driver as well, and solenoid drivers and latch valves. So some of the basic applications are like robotic arms. Okay. So robotic arms, if you have to control and you have to manage them, or you have to rotate them very accurately, then this can be a very good solution. Okay. Printers, so you can see printers. Then tray elevators, there are tray elevators which can be like lifted or something like that. Syringe pumps, in medical devices there are syringe pumps which are used for syringe the injections. There are video cameras. Okay. There are like engraved machine or something like that, x-ray machines. So these are the applications where you can utilize them. All right. Good. Now let us proceed to the data sheet. Coming to the fact of absolute maximum rating. Okay. So you can see there is motor driver pin. Okay. Motor driver supply pin. So that can go up to 42 volt. 42 volt. Okay. But as I suggested you, you try to utilize this IC for up to around 30 volt max. Okay, but I will be giving a design for 12 volt and one more for 18 volt. Okay, so these two applications I will be giving you. There are other pins as well. You can see VDD can go up to plus 0.222 VM plus point 3 volt. So it can go up to more than 42 volt as well. Got it? And you have other fault pins and all those things that you can see that it can go up to around 6 volt or something like that. We have some of the pins like iSense pin is going up to VDD plus 0.3, then enable pin is up to 6 volt, DIN pin is there, then HFS scale is there, half full scale is there, decay modes are there. So all these are 6 volt capabilities. You can see the junction temperature, it can go up to around 160 degrees centigrade. Got it? So as I mentioned, it has two packages. One is TQFN 32 pin package and another one is 28 pin TSSOP package. Got it? So TSSOP package is a bit bigger and it is good. And you can see the thermal capability of TSSOP package is much better compared to TQFN package, which is 1.7 degree centigrade per watt, and it is just 1.5 degree centigrade per watt. Got it? Coming to the fact that electrical characteristics, so this is our most important parameter to see. So supply voltage, it can go up to 36 volt and 4.5 volt minimum. Got it? So for that reason I am going to design for 12 volt or 22 volt and 24 volt, something like that. Got it? It has some more electrical characteristics that you can see by yourself if you want to go very deeper into this. Otherwise, whichever is needed, that I'll tell you. Like 1.8 volt regulator output, it can give you 1.8 volt typical, or it can go up to 1.86 or 1.74. Got it? So there is one regulator which can give you this much voltage. Okay, it has a current limit. It will be minimum 20 milliampere current it can give you. Okay, so if you need to drive a very small microcontroller which doesn't need anything, then you can utilize this as well. Okay, directly, you don't need to uh, drive that microcontroller with any other separate power supply. Got it? So that's the beauty. Next is uh, it has input high level. So if it receives more, like minimum 1.2 volt or more than that, then only it will say that it is high. Okay, and if it is receiving an input low level, then it must be maximum of 0.65 volt or less than that. Okay, so if it is having less than 0.65, then only it will consider as low signal, and if it is more than 1.2, then only it will consider as high signal. So between 0.65 to 1.2, it will not be able to find out whether it is high or low. Okay, so that is called noise margin. Got it? Next, it has a sleep voltage high level is 0.9. So minimum 0.9, if it comes into the sleep pin, then only it will understand that yes, there is a high signal that has come to the sleep pin. And if there is a like a minimum point, a maximum 0.6 volt, then it will consider it as low voltage. Got it? Coming to the some of the production parts, or let's first see the output on resistance. Output on resistance, low side and high side both are 125 milliohms and 125 milliohms. So total R on is 250 milliohms. Okay, so it has very low on resistance, so the heating will be very less. Okay, now, protection circuits, as I told you already, that it has overcurrent protection. So if current is more than 3.8 ampere, it will shut down the device. And that's how it can protect the device to get damaged, right? Then there is over protection blanking time is 2.2 microsecond. So 2.2 microsecond it will wait, and if it doesn't retrace the current, then it will shut it down. Got it? Now coming to the next part. Next part are some of the parameters are under voltage lockout threshold. So 4 volt if it reaches, then it will lock the device and it will not start. Thermal protection is there. So thermal protection, it can go up to 165 degrees centigrade and it will stop. It has thermal hysteresis of 20 degrees centigrade. It means once thermal shutdown has happened, then the device should get cooled down by 20 degree. It means the temperature must reach to 145 degrees centigrade, then only it will start again. Okay, that means the hysteresis. Okay. So hope you are getting this particular point, like what is hysteresis means. Like as soon as it crossed this 165 degree centigrade, suppose it has reached to 164 or 160, then also it will not restart because the hysteresis is 20 degree. Next is reference output voltage is 0.9 volt. Okay, so V reference is 0.9 volt, that you have to consider. And other things are like, let's say current sense monitor. So I sense voltage range is 0 to 1.1 volt. So I sense will be like 0.0 to 1.1 volt range. It has very good current monitor accuracy. All right. So if you see current monitor accuracy, it has, like 5% or -5%, typically is 0.4%. Okay. So typically is 0.4% accuracy is there. Next is it has some of the, sleep time. So sleep time is 150 microsecond, and enable time is around 0 0.4 microseconds. So as soon as you start uh, the enable pin, it will enable the device within 0 0.4 microsecond, and disable time is maximum 0.6 microsecond. So within 0.6 microsecond it will be able to disable. So once enable pin is, rising, so within 0 0.4 microsecond the device will start. Got it? Good. So now we have reached to, some of the typical characteristic that we will see later. There, like it has very good outputs. It has very good supply current capacity, and no load supply currents and everything, and it has good accuracy as well. Okay, let's directly reach to the pin configuration. So as I told you, TQFN pin configurations and TSSOP pin configurations. So we will see their pins and pin descriptions one by one. So let us finish up the pin description of this particular device. So you can see this is TSSOP package. So TSSOP package 28 pins, and rest 4 pins are extra in TQFN package. So in that you can see pin number 25 is one, and then pin number 16, and then 17, and one more is 24. So these 4 pins are not connected pin, so those were the extra pins. Got it? Now moving to the pin descriptions part. So you can see pin number 1 is your ref A, or 30 in TQFN is your ref A. So this is reference A pin. So programmable current analog input. So how much current you want at the output of the motor driver, that will be programmed using this ref A pin. Got it? So you have to connect a resistor from ref A to ground to set the current at the output of motor driver. Got it? Similar connection for ref B. So ref B will also be, giving you the same current. This fault pin is there. So fault pin is active low. So whenever there will be low in this pin, then you will have to understand that the IC is in faulty position. So this is open drain pin. So open drain pins means, I will tell you, like once you have the fault pin here, then you have to keep it pulled to VDD or something like that. Let's say 4.7 kilo ohm I'll keep, and you have to whenever this goes low, from high it goes low, then you have to understand that this is in fault position. Got it? So it goes low for indicating one or more of the protection mechanism that has been activated. Got it? Next, CDR pin. So open drain output, this is also open drain output, current drive a regulator. So what is the current drive that can be monitored through this CDR A and CDR B. Those are 2 pins, 13 and 14. This is your analog ground pin, just you connect it to ground. This is your VM pin, that is motor voltage input. So in motor voltage input, you have to put it this pin. Coming to the other pins, like pin number 8, that is your VDD pin. So 1.8 volt linear regulator output. You have to bypass this for with a 2.2 microfarad capacitors as close as to the device. Got it? And we have driver outputs, out 1 to out 4. So basically, out A, like out 1A, out 2A. That is your first H bridge. Got it? Then out 1B and out 2B. That is your second H bridge. Got it? So these are 4 driver outputs that can be, like used for your stepper motor connections. These are current sense output monitors. So I sense A and I sense B, both the half bridge will be monitored with these two I sense pins, pin numbers 26 and 27. These are DIN pins. So DIN pins are, like PWM pins that you will be giving to the H bridges. So that will be 5, 6, 10 and 11 number of pins, and it is PWM input. So there will be 4 PWMs that will be needed to drive this particular stepper motor. You have enable pins, enable A and enable B, pin number 4 and 9, to enable both the half bridges of the stepper motor driver. We have charge pump output. So charge pump output is 18 volt, 18 number of pin. So pin number 18 is your charge pump output, and you have to connect 1 microfarad between VCP and VM pin as close as possible. Got it? Then CP1 and CP2 pin are charge pump flying capacitor pin. So you have to connect 122 nanofarad capacitor between these two. Got it? Sleep, as I told you already, that you have to put it a input. This is your input pin. So if you put it low, like you have to keep always high. Okay. Once you keep it low, then it will go into sleep mode. So through microcontroller, you can control this particular pin and let the device into sleep mode when it is not in use. So suppose the drive, like a device is not in use, like a stepper motor is not in uh, like action right now. Then what will you do? You will put it in sleep mode by controlling this particular pin and making it low. Got it? So this is how the functionality from microcontroller to this stepper motor driver. This has decay mode setting, DK1 and DK2. So there are 4 modes that we will set using this, either forward or reverse or brake mode, something like that, or fast mode. This has half and full scale this thing. So full scale 0 will be 100% and 1 will be 50%. Got it? So the output current can be set to 50% if you put HFS is equal to 1. So that is your input pin. So again, you have to control through your microcontroller. And this is your exposed pad. So exposed pad is there in both TSSOP as well as VQFN, and you have to connect it to ground. So there are 4 non-connection pin in the TQFN package, and there is no non-connection pin in your TSSOP package. Got it? So these were all about the like pin description. So hope you have understood everything. Now what we will do is we will try to understand the simple application of this particular like IC in our next tutorial. So hope you have understood the applications and the overview of this particular IC. Max 22211, and I'll tell you the benefits that you will be getting by utilizing this particular IC in your projects. Let's say all those projects I mentioned just now, those were what, like printers or motor drivers in robotic arms, or like printers, tray elevators or syringe pumps. So this is how you will be learning it. So hope you have found it useful, and this device is really recommended from analog devices as well. So if you do find any problems or any issues that in using this particular device, then you do let me know. Thank you so much. We'll continue rest of the topics in our next video. Thank you.